Hey guys, so we learned divide and conquer in class this week, and as an example, we mentioned the naive multiplication, and now I want to explain this new algorithm from multiplication, which is called the Karatsuba algorithm, and that has like a slightly better complexity. So we mentioned it in class, but I thought it'd be nice if I can give like a more concrete explanation on this algorithm. So here's the theory part of it. So first, let us assume n is even. By n, we mean the number of digits in the integer, x and y, and then we can rewrite x and y in the following forms. So x will be equal to x left times 2 to the power of n divides 2 plus x right. And there's this like 2 to the power of n divides 2 because x left is like the leftmost like n divides 2 bits of x, but there's no like a multiplication behind the x right term because it's already at like the end of the integer. And we can write y in the exact same way. So x times y will be equal to the two multiplication, the multiplication of the two new forms of like the original integer, and then we would have n to the power of n times x left times y left plus this big long term plus x right times y right. But this is not enough because if we observe it more closely, we still have four different multiplications: 1, 2, 3, 4 in this long equation, and each multiplication is between an integer of half of the size of x times another integer of half of the size of y. And if we do a little bit of mathematics, we will realize the time complexity of this algorithm, like this equation, it's still O(n) squared. So there's no improvement from the naive algorithm to this equation. That's why we need to do a little bit of math tricks in the next slide, which is right here. We can write x left times y right plus x right y left into this equation. If we break the brackets, we will easily realize that they're exactly the same value. And then we can plug this long equation back into where we saw there were like two multiplications in like originally in this like long bracket. And then we get this new formula, and I won't read it loud because obviously you can see it. And now if we count again, we can see there are only three different multiplications: 1, 2, 3. And these two, they're respectively the same as the first one and the last one. So we just need to record their result and then plug it in back here. And now we officially get the way to calculate the time complexity to this new algorithm, which is Tn is equal to 3t n divided by 2 plus On. And here's like n divided by 2 because again, x left, y left, they are multiplication of integers of like half of the size of x and y respectively. And the solution to this recurrence is like O(n) to the 1.59, which is, I think we briefly mentioned in the class, like 1.58. But yeah, so I hope you enjoyed this video. Thank you.